4.2.0 Lockout Tagout Requirements. If you go on a job, they're going to go over lockout tagout procedures with you. This is a very important part of safety. It's disconnecting any power source, and by power source I mean electrical, hydraulic, pneumatic, steam, any kind of power source. They're going to lock it out, tag it out, release any stored energy. So if it's a RAM, they're going to lower the RAM to the lowest position. That way nothing can go wrong and no one's going to get hurt. But here's our lockout tagout, and this is from OSHA, the Occupational Safety and Health Administration. Lockout tagout procedures safeguard workers against unexpected releases from various energy sources. An energy source can be electrical, mechanical, hydraulic, pneumatic, chemical, or thermal. And I think somebody also listed gravity as a source of energy, something that is being suspended. It can fall. So these are different types of lockout tagout devices. They call this a spider. If more than one person needs to put a lockout on a circuit, you'll put a spider on it, and you have 6 different slots here for locks. So 6 people can use this same spider. A lot of times they'll use a lock box where you only need one lock on the device, but the key to the lock on the device goes in a box, and then multiple people can put locks around that, the rim of the box. It keeps the box sealed until everyone is aware and in agreement that the power will be restored. That way nobody gets hurt. Here's a lockout for a valve. They turn the valve, close it, and then put this lockout on it so no one can turn the valve on. Electrical cord safety. It says every electrical cord should have an Underwriter's Laboratory label attached to it. Check the UL label for specific wattage. Do not plug more than the specified number of watts into an electrical cord. Here's a highlight. It says generally each lock has its own key, and the individual who applies the lock keeps the key. That's very important. If you're a worker on a job and they give you a lockout and you lock whatever it is that you're going to be working on, you keep the key. You don't give the key to the foreman. You don't give it to another worker. Like, hey, I'm going to use the restroom or whatever. Here's my key for the lockout. No, you keep that key in your pocket. And at the end of the day, you are the person who will take that lock off. The authorized person who applied the lock must be the one to remove it. Okay, that's it. And these are tags that you can put. Danger, live wire, do not remove this tag. They'll usually put a tag. If it's just one person or one crew, they'll put that person's name or the crew name. They'll give a contact number if someone needs to get in touch with the foreman of that crew. But again, no locks are going to be removed other than by the person who put them on, and the power will not be restored until every worker is aware that the power is going to be coming back on. Okay. These are for circuit breakers. There are different ways. This is for a cord. You can put it over the male plug on the extension cord or on whatever tool that you're working on. You lock it up, and then it cannot be plugged into the wall. This goes on a ball valve. This goes on a circuit breaker. This is on a switch on a wall. Different lockout methods. And here's your spider with the different locks on it. It says multiple lockout tagout device. When you're on the job, check with the safety administrator, because I don't know if they still use these. I thought I heard that they're not used on the job anymore because they were of a cheaper material and they can be bent out of shape. So I don't know if that's true. Um, we used to have a saying, it keeps honest people out. When you put a little tiny dinky lock on something, it's just to keep honest people out. It's not to keep, someone who has ill intention. They can get in there, but you're not supposed to manhandle those spiders. You shouldn't bend them. Just put your locks on, take them off. So, and here's what I was saying. It says the exact procedures for lockout tagout will vary by organization and site. Check with your instructor or site supervisor regarding the detailed lockout tagout procedures at your site and be sure you're familiar with the proper steps. On a job, any locks used for lockout tagout have to be identifiable. They have to be different. They're a different color. Usually they're red, like the lock themselves will be of a red color. They won't just use a regular master lock like this picture shows us. The locks for lockout tagout are specifically designed for lockout tagout. And like I say, the ones that I've seen are red in color, and there are no other red colored locks on the job. And the key won't come out of the lock until it's in the locked position. So when you put your key in and you turn it and you unlock the lock, you can't get your key back out. It stays in the lock until the lock is back in a locked position. And it's against the rules to use a lockout lock to lock your toolbox. You're not supposed to use a lockout lock for any other purpose other than lockout tagout. I won't say I didn't get in trouble, but I had somebody tell me once, you need to take that lock off of your tools. I had a lockout lock and I just used it to lock my toolbox, and they said you can't do that. So I didn't give them a hard time. I took it off. Okay. Pressurized or high temperature systems. Many jobs require that workers be close to tanks, piping systems, and pumps that contain pressurized or high temperature fluids. Be aware that touching a container of high temperature fluid can cause burns. Again, we were talking earlier about proximity work. If you're working near something that's very hot, that's proximity work. You have to keep your wits about you so you don't accidentally lean up against something hot and get hurt. Purpose of double insulating an electrically powered tool is to protect the user from electrical shock. When a lockout is performed, the key to the lock is kept by the person who applied the tag or the lock. Very good. 5.0.0 Personal protective equipment. Every part of your body that can be exposed to hazards on the job, they have made some protective equipment for it. So for your eyes, they have safety glasses and goggles. For your face, there's the face shield. For your head, there's a hard hat. They have knee pads. They have toe caps that are metal that if you're moving something that's extremely heavy, those metal toe caps will protect the front of your shoe. Even if you're wearing a steel-toed shoe, you still have to use those toe caps because they're rated at much higher strength than the fronts of your steel-toed shoes. And a lot of people are going to composite toe shoes, not steel. Especially us electricians, we don't like steel on our shoes. So it says performance task. You'll be asked by your instructor to inspect the following personal protective equipment items and determine if they're safe to use. Eye protection, hearing protection, hard hat, gloves, approved footwear, and you'll properly, there's that word again, don and doff. You properly don, fit, and remove the following personal protective equipment items: eye protection, hearing protection, hard hat, gloves. So that's a little bit of a performance that you'll do. You'll show that you can do those things. It says every worker is responsible for wearing the appropriate personal protective equipment on the job. When worn correctly, personal protective equipment is designed to protect you from injury. You must keep it in good condition and use it when you need to. I've seen, not in real life, but I've seen in movies where motorcyclists have a helmet on, and when they get off their bike, they throw the helmet down on the ground. They slam it down on the ground as hard as they can. And it's really cool. James Dean and whatever. If you're relying on something to possibly save your life, don't mistreat it. You don't want to get your hard hat to a point where it is just hanging on. Because if something falls and hits the top of your hard hat could shatter into several pieces, and then you're going to get hurt. Whatever it is that's falling is going to hit you on the head. So take good care of your personal protective equipment. Don't be a James Dean. Personal protective equipment items. Here she's got a high visibility vest. I don't know where she's working. There might be a lot of vehicular traffic, trucks, forklifts, road machinery, who knows. But she's got a high visibility vest on here. Oh, that's a video. I don't like to watch the videos. Remember, while personal protective equipment is the last line of defense against personal injury, using it properly and taking care of it are the first steps toward protecting yourself on the job. Yes, personal protective equipment is not the first line of defense. There's administrative ways to take care of a problem. There's engineering solutions. You can mitigate the problem. You can move valves and things, get them out of high noise levels or high temperature areas. You can put the controls for those devices in a lower temperature area so nobody has to go in there with a cooling vest or what have you in order to operate the valve. You can do it remotely. These are engineering and administrative. Administrative controls are, you need a work permit to enter this room. You can't just walk in there. So when you go to get the work permit, then they will alert you of any hazards in the area. They'll make sure that your PPE is correct for the area. That's an administrative control. So there are different ways. The last line of defense is personal protective equipment. We've taken all the precautions we can. You have to climb up on this ladder anyway. So now we're going to give you a safety harness, and we're going to have you anchor to a point above your head so that if anything does happen where you fall off the ladder, this fall protection will keep you from getting hurt and possibly dying. So, protective equipment commonly worn by craftsmen, craft workers on any job site usually include the following: hard hats, eye and face protection, gloves, foot and leg protection, hearing protection, respiratory protection, high visibility clothing. You should only have to pay for your work boots. If you go on a job, if you have a job interview and they say, show up to the job with hard hats and eye safety glasses, it kind of says something about the company. I've had students tell me before that they were told that they had to go to Home Depot and buy their own hard hat and safety glasses. You can get a hard hat for 15 or 20 bucks. It's not the greatest hard hat, but it'll protect you. You know, it's ANSI, American National Standards Institute. It's been checked and it has been certified to be of a certain strength and durability. But still, you should not have to. You shouldn't have to supply those yourself. Sharing PPE, it's not a good idea for workers to share personal protective equipment. If one person has an infection, it can be passed to another through the shared equipment. All right, I'm gonna try to go through these quickly here. Here's a typical hard hat. Protects your head. They have different ratings of hard hats. We as electricians will want to use an E rated hard hat, E for electricity, G is general, and there are a couple of other categories. And it says hard hats were once made of metal, however, metal conducts electricity. So most hard hats are now made of reinforced plastic or fiberglass. Eye and face protection, again, the American National Standards Institute, ANSI, they need to be, I think, Z87, C80, Z87E or something to qualify as safety glasses. I'm going to tell you something that I didn't believe when I first heard it. A ANSI Z87 safety glass, you can shoot it with a .22 caliber bullet and it will not shatter the glass. It will not go through. And you can go on the internet and find videos of people doing just that. And it's made in such a way that that plastic, the way it was explained to me is that if a projectile like a nail goes toward the lens, the heat of the nail melts the plastic, and before the nail gets all the way through the plastic re-hardens and stops the nail. And you can see videos of people who've done that. They've shot safety glasses with a nail gun, and the nail just protrudes just a little way through, but it's not far enough to affect your eyes. But that plastic lens will grab that nail before it gets to your eye. All right. Face shields, that's for your whole face, for filings and flyings. If you're doing any kind of welding, you need shaded protection. The lenses are rated for darkness, and you need, I think, a minimum of a 9 or a 10 in order to do welding. You really want a 12. If you're not the person doing the welding, someone else is welding, you're just standing around, you want welding glasses or goggles that are at least a 12. You want really dark. All right. Case history. I'm not going to read the case history. Here's a highlight. It says welders, helpers, and all employees working in the vicinity of arc welding are also required to use eye protection with the prescribed level of shading. So there you go. That's what they're talking about right there. You need to protect your eyes. Hand protection, you'll be, either you purchase your own or you'll be afforded gloves on the job. Hopefully they're going to give you gloves. I think it's proper for the contractor to. Foot and leg protection, again, safety shoes, that's personal item. You're going to pay for those. Hearing protection, they've got earplugs, they've got ear muffs. Here's the ear muffs that deaden the noise level. There you go, the sound level. You're allowed to work an 8-hour day in a decibel level of 90 decibels on the A-weighted scale for an 8-hour day. Anything above 90 and you have to reduce the amount of time that you're exposed to that noise, or you have to wear earplugs. So the way I explain it to my students is that if your foreman brings you into a machine room and there are machines just screaming in the background, and he takes you in there and he says, we need to put a disconnect up on this wall. We need to run the pipe up and over. And you're in there for 2 minutes. You haven't ruined your hearing. Yeah, if you've got earplugs, go ahead and throw them in. But you haven't really done anything detrimental just by being in there for a couple of minutes. The higher the decibel level, the less time you can be exposed to that noise level. So if he's just explaining something to you, hey, I want to show you this real quick. Okay, you get in, you get out. Then when you're going to work in that room, that's when you want to have the earplugs and earmuffs. The earmuffs are much better at deadening the sound than the earplugs. But they're rated on how many decibels they will subtract from the ambient noise level. So if you're working in an area that's 105 decibels, you're going to need at least a 15 decibel earplug to bring that back down to 90 decibels. Okay, I'd always want to go more, go 20 or 25. You know, I'm not sure what their ratings are. They've got weird, like 32. It's like, all right, who decided it would be 32? All right, here's 115 decibels. You can be in there for 15 minutes or less. Okay, all right. Respiratory. If you're ever on a job where you have to wear a respirator, they're going to send you to training. They're not just going to hand you a respirator and say, hey, go in this room, there's asbestos in there, and we want you to go and install a box. They'll send you to training. You have to be qualified. You have to take a physical. You have to be physically able to wear a respirator and to go into a hazardous atmosphere. Okay. So you will be fit tested to make sure that you get a good fit. Silica is a mineral found in concrete, masonry, and rock. Silica dust is created when cutting, drilling, or performing similar tasks on materials containing crystalline silica, and it's harmful. You can get silicosis. Silicosis is a serious lung disease resulting from the inhalation of crystalline silica particles. So you need a respirator, even sometimes just a dust mask. But if you're doing any kind of cutting, if you're cutting fiberglass or if you're cutting concrete, you need to have some kind of a respirator. I'd say at least a half face mask, not a full face mask, but a half face mask. Covers your mouth and your nose, and it has the canisters with the filters. It's going to keep you from inhaling anything bad. Warning: when you're working in an area where silica dust is present, you must use the appropriate respiratory protection. Never work around silica dust without proper training, authorization, and personal protective equipment. And again, when they send you to training, they're going to teach you how to don and doff that respirator, how to take it off without getting the particulate in your hair and in your lungs and what have you. All right, I'm just going to go ahead here. Again, there's a lot of good information here. They're cutting concrete. I like it when they use what's called a wet method, wet sawing. They drip water onto the blade, and when they're cutting this concrete, it turns the dust into mud, so it doesn't become airborne. It pretty much stays on the ground, and then later on they can sweep it up or use a flat-nosed shovel, and they can just scoop it up and put it in a wheelbarrow. Concrete, if you cut concrete and you get concrete dust, you could take that concrete dust and put some water in it, stir it up, and you'll have concrete that you can then pour into a mold and it'll harden and you'll have a concrete statue. If that dust goes into your lungs, you have a lot of moisture in your lungs. It will rehydrate that concrete, and then the concrete will harden and you won't be able to breathe. So you really do not want to breathe in concrete dust. What you're doing is you're putting concrete in your lungs, and it's not good. Don't do it. Okay. And that's the same for drilling. You should have at least a dust mask on if you're drilling into a concrete floor or a pillar. You just try to stay out of the dust, but really you should be wearing some kind of a face mask for protection. There's a HEPA filter. It's supposed to filter the air and keep everything hunky-dory. Other respiratory hazards, like they said, asbestos and silica. Basically, if you have tiles and you don't know if they have asbestos, you don't know if they're harmful to you, those tiles, if you snap them and they break clean, it's okay. You can take them out without harmful, you can always err on the side of caution. Wear a respirator or a dust mask anyway. But if you snap them and you see little fingers like fiberglass, you break them, and when you pull them apart, they have those little needles, little fibers. That's the bad stuff. Fiberglass, asbestos, anything like that that leaves those needles, that's what you want to watch out for. That's when you need to wear the either half face mask with the canisters or a full face mask with the canisters. You don't want to mess with that stuff. That's what gets into your lungs and gives you asbestosis. Asbestos use around the world. Asbestos was identified as a health risk many years ago. I think they outlawed it in Great Britain in the 1950s. I think we outlawed it in 1981 or something, or 1978. So, World Health Organization. Types of respirators, you've got self-contained breathing apparatus, supplied air mask, full face piece, mask with chemical canisters, half mask or mouthpiece with mechanical filter. So there's your full face mask. This is a self-contained breathing. You bring your tank just like you're underwater. That's the only difference between scuba, underwater, the U, they took it out. Self-contained breathing apparatus. Here's supplied air. So this guy has a hose and it's giving him fresh air. Here's full face mask with canisters. Here's the half face mask with canisters. Okay. A half mask or mouthpiece with mechanical filters used in areas where you might inhale dust or other solid particles. I think there's a question on one of the tests that talks about an emergency situation. You have to get out of the area quickly. Which one do you use? Just grab the half mask. Like you're just trying to exit the area. Just grab a half mask and get out of the area. Okay. Wearing a respirator, they're going to send you to respirator school. Selecting a respirator, they'll do that for you. Okay. Personnel working in the vicinity of arc welding must wear eye protection with tinted lenses. True. Drilling concrete requires the use of a respirator because it produces silica dust. All right. I should probably just skip all those questions. I'll let you do them. Job site hazards. I know we've been doing this for about 2 hours now, but we're in the home stretch. I'm going to try to wrap it up here. Job site exposure hazards. That's your hazardous communication standard, or your right to know, and that's one of the questions. It's also known as what? It's also known as the right to know standard, the hazardous communication standard, or they shorten it to HAZCOM, the HAZCOM standard, also known as the right to know. Okay. Any chemicals you're using on the job, you should have a safety data sheet. Chemical exposure is subject to permissible exposure limits, PELs, permissible exposure limits. So they'll tell you 2 parts per million, that's fine, or 10 parts per million. They'll tell you your permissible exposure level. And then there's an upper level, UEL, I think. And then anything above that you cannot be exposed to. Lead, don't eat the lead paint. Bloodborne pathogens, anything that can be transmitted, hepatitis, AIDS, HIV. If somebody gets hurt on the job and they're bleeding, take every precaution you can to administer first aid to them quickly, but also keeping yourself safe. I've had instructors even say, if you have nothing else, but you have an unused trash bag, use the trash bag to wrap the person's injury around so you don't get any blood on yourself. If you don't have surgical gloves or what have you, you don't have a pair of those first aid gloves handy, just wrap it and put pressure on it. Apply pressure to keep it from bleeding, but use the trash bag to separate, to put a barrier between you and the person's bodily fluids. Chemical splashes, again, if you're working in an area that has chemicals that are dangerous, they're going to teach you about them. They're going to teach you the proper ways to transport those. We're construction workers. We really, the kind of chemicals we'd be using is maybe muriatic acid or sulfuric acid. And as an electrician, I've never used any of those. But they are used sometimes to cure concrete or what have you, or to make concrete have a certain texture to it. So they very well can be used on the job. You need to be aware of it. If you see anyone using it, know to stay away from it. Remember to wear the prescribed clothing and personal protective equipment on the job site at all times. This will help guard against your skin and eyes being splashed with chemicals. Um, Container labeling. Every substance that is not drinking water has to have a label. One of my questions that I ask my students is I say, what is a hazardous material? And the answer is anything other than potable drinking water. Something as ineffective or uh, Vaseline. Like you have chapped lips and you put Vaseline on your lips. Your baby has diaper rash, you put a little Vaseline on their bottom. Vaseline is non-harmful. But if you work in a vat or in a plant where they make Vaseline, if your hands were covered with Vaseline for 8 or 10 hours, something will happen that's called defatting, where the Vaseline gets absorbed through the skin and your fat layer underneath your skin separates from your skin. They call it defatting. And then bodily fluids will collect between the skin and that fat layer, and your hands swell up like balloons. And it may not be life threatening, but it's very painful, and you'd have to be taken to the emergency room. They'd have you in the hospital for a day or two until those bodily fluids will be taken off by the body naturally, uh, mitigating the circumstances. So they have to have a warning label on the Vaseline telling you that overexposure for long periods of time is harmful. That's what the Hazardous Communication Standard does. That's from OSHA, Occupational Safety and Health Administration. They say any worker on a job who is exposed to any product that could cause harm has a right to know about that harm, about that chemical. So that's what this is all about. And here they're going to tell you if it's flammable, if it's an oxidizer, if it's explosive. They'll tell you the health hazards. Is it a carcinogen? Does it cause cancer? Reproductive toxicity, respiratory sensitizer. It'll also tell you on that label the precautions to take, what PPE you need to use while using that chemical, and what to do in case of exposure. How can it enter the body? You can eat it, you can inhale it, it can get in through your eye sockets, it can absorb through the skin. What are the different safety levels, those permissible exposure levels? All of that will be on those labels, those safety data sheets. Every shipment of chemicals has to have a safety data sheet with it. And here's radiation, radioactive. That's what this three-bladed symbol means. It's radioactive. Biological hazards. Biological hazard signs are used to warn workers of the actual or potential presence of a biological hazard. Biological hazards or biohazards can be any infectious agents that create a real or potential health risk. So that's the symbol for biological hazards. Evacuation. In many work environments, specific evacuation procedures are needed. These procedures go into effect when dangerous situations arise, such as fires, chemical spills, and gas leaks. Uh, Here's that wind sock. I mentioned it earlier, I think. Some sites may have a wind sock that indicates the wind direction. Different evacuation routes are planned for different wind directions. Taking the right route will keep you from being exposed to the hazardous materials. You're supposed to run perpendicular to the wind sock, a cloth cone open at both ends, mounted on a high place to show which direction the wind is blowing. So as the wind blows through that sock, you've seen them at airports, I'm sure. There are different places that have wind socks. Environmental extremes, heat and cold. Heat stress. Heat stress occurs when abnormally hot air or high humidity or extremely heavy exertion prevents your body from cooling itself fast enough. So you want to make sure you drink plenty of water. Don't drink alcohol or caffeine on the job. I drink caffeine all the time. So when possible, perform the most strenuous work during the coolest part of the day. Wear lightweight, light-colored clothing. I always wore sunscreen. It helps. Even short trips, if you're going outside to go to the van or what have you, that sunscreen helps to mitigate the heat of the day and of the sun. Um, Drink plenty of water. I think some places suggest that you should be drinking water every 15 minutes. I know that the foreman doesn't want to hear that, but go to that water cooler at least once an hour and drink 2 or 3 of those tiny little cone cups. Drink 2 or 3 of them every hour. Make sure that you stay well hydrated. And if you just happen to feel thirsty, listen to your body. Go get some water. Uh, you can have heat stroke. You can have heat cramps. Okay. Which one was this? This is heat stress. Painful muscle spasms, cramping, pale, sweaty skin, normal body temperature, abdominal pains, nausea. Okay. Heat exhaustion. Symptoms of heat exhaustion include cool, pale, and moist skin, heavy sweating, headache, nausea, vomiting, dilated pupils. If your body is still sweating, that's a good sign. It means that you still have water. What's bad is when you're overheated and you're not sweating because you've used up all the spare moisture, and now you're just cooking your brain, and that's when you get heat stroke, and it's fatal. You can die from it. So here in Florida especially, you want to make sure that you don't overheat yourself. Make sure you're drinking plenty of water, stay in the shade. Heat stroke. Heat stroke is life-threatening. The body's temperature control system, which produces sweat to cool the body, stops working. Body temperature can rise so high that the brain damage and the death may result if the body is not cooled quickly. Don't ever throw ice water on someone. If somebody's experiencing either heat stress or what you think might be heat stroke, don't get ice water from the cooler and throw it on them. What you should do is take a damp cloth and put it on their forehead and on their neck and on their wrists, and you should have them sip room temperature water. Have them sip water slowly. Don't guzzle it. Don't, try to drink a gallon of water. Just take little sips. Introduce water back into your system and try to sit in the shade, lie down, and put those cold compresses, the wet rags, on the victim. The symptoms of heat stroke include the following: extremely high body temperature, hot, dry, or spotted skin. Your skin's dry because you have no moisture to sweat out. Very small pupils, mental confusion, headache, vision impairment. That headache, if you're working in the sun and you start getting a headache, go get in the shade and drink some water. Okay. Cold stress. When your body temperature drops even a few degrees below normal, which is about 98.6 degrees Fahrenheit, you can begin to shiver uncontrollably, become weak, drowsy, disoriented, unconscious, or even fatally ill. Now, I had a student once, English was not their first language, and they didn't know this word, shiver. Shiver is when you're cold and your body shakes. What your body's trying to do is to warm up. And so it's involuntary. Your muscles are shaking you to try to warm up your body. That's shivering, in case you don't know what shiver is, okay? Shiver. In fact, you know what? I am going to highlight that word. It asked me if I wanted to. There, shiver. So if the question is asking you about which one of these and one of the symptoms is shivering, it's cold stress, not heat stress. Frostbite. Yeah. My understanding is frostbite is when the moisture in your blood and in your tissue starts to freeze. So the water in your veins freezes into little ice crystals, and the ice crystals running through your veins are like little knives, and they cut the inside of your veins and your capillaries. That's not good because that causes internal bleeding. That's why a lot of times when you see on TV or movies, what have you, they say somebody had frostbite. They make the area look purple because it's bruised, because the blood is not inside of the capillaries anymore. And they'll probably have to lose that foot or that appendage if it's fingers on the hand or if it's the whole hand. They want to stop the death of the body. The tissue has started dying. It's gangrenous. And if they don't stop it, it will eventually lead to the heart and kill you. So they'll have to take off that appendage that has frostbite in order to save your life. Frostbite is a dangerous condition that can have lifelong effects on your body. It usually affects the hands, fingers, feet, toes, ears, and nose. Symptoms of frostbite include a pale, waxy white skin color and hard, numb skin. Never rub the affected area because, again, if you have ice crystals in there and you start rubbing them, you're going to be cutting the inside of your capillaries. This can damage the skin and tissue. After the affected area has been warmed, it may become puffy and blistery. The affected areas may have a burning feeling or numbness. When normal feeling, movement, and skin color have returned, the affected area should be dried and wrapped to keep it warm. If somebody's been outside and you suspect them of having frostbite, don't bring them in and put them in front of a heater or a fire because they can't feel their limbs, they can't feel their extremities. So now their feet might be too close to the fire and they're roasting like you're actually cooking, doing more damage to the appendages than if you just put them in a warm blanket. Just wrap them in a warm blanket, bring them inside. Again, don't give them hot liquids to drink. You can give them warm tea, warm soup, but not hot. You don't want to shock the body. Hypothermia is a serious, potentially fatal condition caused by loss of body heat. You do not have to be in below freezing temperatures to be at risk for hypothermia. Hypothermia can happen on land or in water. So the effects of hypothermia are gradual and often go unnoticed until it's too late. Make sure that you're staying warm if you're outside. It's a real problem in the water because, like they said, above freezing, if you're in 60-degree water, it can lower your body temperature to a dangerous level. That's hypothermia, when your body temperature drops. Okay. I think we're about to wrap it up here. What is this? Hot work hazards. Welding and torch cutting of metals is done using heat that's high enough to melt steel. In addition, most flame cutting and some welding processes are done with flammable gases. For those reasons, such processes are classified as hot work and are subject to special safety precautions. So you'll probably have to get a hot work permit if you're doing hot work. There are some places where you cannot do any hot work because of the atmosphere could be explosive, so you can't do any hot work. You have to, if there's something that needs to be welded, it needs to be removed, taken out of the area, welded out in the open, and then brought back in. Arc welding. Again, if anyone is welding in the area, you need to be wearing special eye safety wear if you're there. If you're not helping that person, you're just walking by, then no, you don't have to have special glasses. But shield yourself from the welder so that you don't get flashed. You don't want your eyes to be hurt, damaged in any way. There's an arc shield. It filters out the UV, the ultraviolet. It filters out the harmful rays from the welding. So you'll see those on jobs. Oxyfuel, cutting, welding, brazing. Again, you have to have special eyewear if you're going to be cutting with welding or brazing. So-called oxyfuel is commonly used to cut and weld steel to join copper pipe by brazing. Brazing is a process using heat in excess of 800 degrees Fahrenheit to melt a filler metal that's drawn into a connection. Brazing is commonly used to join copper pipe. So we kind of call it soldering, but it's brazing. Oxyfuel. So you've heard of oxyacetylene, oxygen and acetylene. That's what they're talking about, oxyfuel. Some gases, such as acetylene, are highly flammable. Oxygen is an explosion hazard if it comes into contact with grease or oil. Flammable compressed gases have additional stored energy besides simple compression released energy. So the cylinders have to be separated by at least 20 feet or by a steel barrier 5 feet high. You can't store those tanks together. You see this metal plate. This qualifies as separating these two, just having that steel plate. So a lot of times you'll see they have a storage area where you have the acetylene stored on one side and the oxygen stored on the other of this metal barrier, or they'd have to separate them, I think, by 20 feet. I'm going by memory, and that's a bad thing to do. There you go. Flammable. Keep fire away. Oh, there you go. 20 feet. Like a steel trap. Lined like a steel trap. Or you can have this metal barrier 5 feet in height with a half-hour fire rating. Warning, keep oxygen away from sources of flame and combustible materials, especially substances containing oil, grease, or other petroleum products. Compressed oxygen mixed with oil or grease will explode. Never use petroleum-based products around fittings that serve compressed oxygen lines. Okay, there's that Vaseline again. There's a petroleum-based product. Vaseline is a petroleum-based product. So don't use it on your baby's diaper rash. It could explode in the presence of pure oxygen. Transporting and securing cylinders. Hot work permits. A hot work permit is an official authorization from a site manager to perform work that may pose a fire hazard. So the permit has to be signed, and I think it's posted in the area, and then they keep it on the site for a year to make sure that everything's up to snuff. Fire hazards and fire fighting. How fires start. You have to have three things. It's the triangle, right? You have to have fuel, heat, and oxygen. If you remove any one of those things, you'll put out the fire. So a lot of times you're I'm mine's just gone blank, sorry. Fire extinguishers, what they do is they remove the oxygen. They'll engulf the fire and not allow it to get any oxygen. It'll put out the fire. The flash point, that's the temperature at which fuel gives off enough gases to burn. That's the flash point. Here's your fire triangle: fuel, heat, and oxygen. Remove any one of those and the fire goes out. Combustibles are categorized as liquid, gas, or ordinary combustibles. The term ordinary combustibles means paper, wood, cloth, and similar fuels. Liquids can be flammable or combustible. So, fire prevention: remove the fuel, remove the heat, or remove the oxygen. Basic firefighting. There's that qualified person who, by possession of a recognized degree, certificate, or professional standing, or by extensive knowledge, training, and experience, has demonstrated the ability to solve or prevent problems related to certain subject, work, or project. Also, a person who, through the possession of a recognized degree, certificate, or professional standing, or one who has gained extensive knowledge, training, and experience, has successfully demonstrated his or her ability to solve problems relating to the subject matter, the work, or the project. Boy, deja vu. Sounds like I read the same thing twice. All right. So here's your fire extinguisher. Activation lever. Here's a tamper seal. A lot of times that tamper seal is very easy to break, and you don't even have to worry about trying to remove it. When you squeeze this handle, that tamper seal is going to break. So just pull the pin and aim the nozzle, the hose, at the fire. At the base of the fire, do a sweeping motion back and forth, back and forth. Using water on a Class C fire could cause you to be electrocuted because water conducts electricity. So we want to use a Class C fire extinguisher for any electrical fires. Here's your different ratings. A is trash and wood, B is liquids, C is electrical equipment. I think D is chemical. So here's ordinary combustibles, flammable liquids, electrical, and then this is a type ABC. That's the best one to have. If you're going to buy a fire extinguisher for your home, buy a type ABC. It does everything. And there you go. There's Class D, combustible metals such as magnesium and sodium. So combustible metals. Again, there's a lot of really good information in here. I want you to go back and read the book. I don't want you to just think that if I didn't go over it, it's not important. It is. But I'm trying to hit the high points, and I don't want the video to be 6 hours long. I think I've already gone over that. Using a fire extinguisher: pull, aim, squeeze, and sweep, back and forth. Again, you don't need to be doing this. If you haven't been specifically trained to use a fire extinguisher and you're not certified, if you're in a building, get out of the building. Call the fire department. Don't think that, I'm going to save everybody. If you have a certification and there is a fire extinguisher on the wall, then okay, yeah, And as a last resort, if you're the only person there and there's a fire, well, do what you can. But basically, just get out of the building and call 911. Call the fire department. They know how to deal with it. Yeah, here's that tamper seal, but it's very thin plastic. It's very easy to break. You don't have to worry about removing it. Just take the pin and grab it, pull it. It'll break that seal, that tamper seal. There you go. Pull ring pin. Start from 8 feet back. Aim at the base of the fire. Use extinguisher upright. Squeeze the lever and sweep from side to side. Okay, confined spaces. A confined space at one time was described as being only having one entry or exit. that is 30 inches or less. It's not meant for continued habitation. A confined space is a space that's large enough to work in, but not that has limited means of entry or exit. A confined space is not designed for human occupancy, and it has limited ventilation. Examples of confined spaces are tanks, vessels, silos, storage bins, hoppers, vaults, pits, and certain compartments on ships and barges. So, a tank, a pipe, a silo, a manhole, these are all confined spaces, and you have to get a confined space work permit. Permit required confined space. A confined space that has been evaluated and found to have actual or potential hazards such as a toxic atmosphere or other serious safety and health issues. Workers need written authorization to enter a permit required confined space. Okay. If it's a permit required confined space, you have to get a signed entry permit before you can work in that confined space. And there's a whole big long procedure we're not going to go into. They've got these little electronic sniffers. Basically, you put it down there and it'll tell you if the oxygen level is, in that sweet spot. It's not too low, it's not too high. You don't want it to be over, I want to say 23% oxygen. You don't want it to be too high. You get loopy. You want to check for flammable gases, methane, or any gases that are ignitable, and you want to check for CO2, carbon dioxide, and carbon monoxide. So that sniffer will do all of that. And you get 3 green lights, and you go, okay, we can go in there. Written authorization, commonly known as an entry permit, is required in order to enter a permit-required confined space. Okay. So here's an example. This guy is down in a manhole. He's welding. He's got a ladder. Now, he's wearing a harness, and you think, well, there's no way for him to fall. Why is he wearing a safety harness? That's so that his partner can get him out with this winch if he passes out. If something goes wrong and he passes out, this gentleman should not climb down the ladder to save him. If there's an accumulation of some kind of gas in this manhole that caused him to pass out, if his helper comes down the ladder, guess what? He's victim number 2. So he calls to his buddy. His buddy doesn't answer. He looks inside. He sees that he's lying on the ground. He starts cranking this winch, clicky, 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 to pull him up out of that hole, to get him out, to get him to safety. Okay. You don't jump in on top of him. All right. Permissible exposure level, or exposure limit, excuse me. A condition in which the body temperature drops a few degrees below normal is is cold stress. Swollen eyes and sandy feeling in the eyes are symptoms of flash burn. When you get flash burn, it feels like you have sand in your eyes. 3 elements needed for a fire to start are fuel, combustible liquid, and oxygen. False. Now, combustible liquid would be a fuel. You need heat, fuel, a heat source, and oxygen. A confined space is an enclosed space that has limited access. They've changed the definition. They don't say it only has one entry or exit. They just say it has limited access. Okay. All right. Very good. Well, so this concludes our 00101 basic safety. Again, if your instructor has you signed up for OSHA 10-hour course, a lot of what we went over here is in that OSHA 10-hour course. Very good. All right. Signing off. Hey, this is Brian Young. If you liked my video, please give it a thumbs up and consider subscribing. I'll see you on the next video.